Welcome to the Izumo-class helicopter destroyer ship brief. The Izumo-class is a class of 2 ships that are designed for anti-submarine warfare by carrying anti-submarine helicopters to the fight into the Pacific waters around Japan and its chain of islands. It is operated by the Japanese Maritime Self-Defense Force and is a replacement to the Shirain class destroyers. One of the big reasons or purposes of this ship for replacing a destroyer is the size of the theater, the Pacific Ocean, specifically the Western Pacific around Japan, even as a defensive force, is simply too large to efficiently cover an ASW search with destroyers. So Japan decided to build aircraft carrier style ships, but limit them to only helicopters for the purpose of ASW warfare. That is the primary mission of the Izumo class. But the Izumo class is undergoing a transformation right now with the help of the United States. They are working with the Marine Corps at the time of this recording in 2024 to operate F-35 Bravo VTOL aircraft off the coast of San Diego. They're undergoing this change and will be fully converting both of these ships to F-35 aircraft carriers. That's in progress in 2024. The size of the ship is still quite impressive. It is 248 meters in length and displaces close to 27,000 tons with a full load of aircraft. This number will change slightly between helicopter and F-35 Bravos, but not enough to be significant. Just know that it's in the realm of 27,000 tons. The propulsion system here is the co-gag system. It is combined gas and gas turbine propulsion. She has a total of 4 of the LM-2500s. For defensive weaponry, she has 2 C-RAM point defense missile systems and 2 Mark 15 Phalanx Sea-Whiz systems. The offensive capability of this ship comes solely from her aircraft, whether that's the SH-60J helicopter for ASW warfare or the F-35 Bravo for air combat and air-to-ground strikes. Let's start with the weapon systems that are on board the ship. There's only a few. If we look at the bow center line, right in the middle of what would normally be a flight deck, but off the bow of the ship, is a Phalanx close-in weapon system. That's one of 2. Behind that, on the starboard side, just below the bridge, is the first C-RAM point defense missile system. Now, both the C-RAM and the Sea-Whiz use the same sensor suite, so that's why they look similar to each other. But what's different is the payload. The C-RAM uses the RIM 116 rolling airframe surface-to-air missile for self-defense, whereas obviously the Phalanx uses the Gatling gun style 20mm gun. On the aft end of the ship, there is a Sea-Whiz and a C-RAM, 1 port, 1 starboard, for a total of 2 C-RAMs and 2 Phalanxes working together to protect the ship from all angles. For the sensors and countermeasures, she has quite a few, but not anything that you wouldn't expect from a sub-hunting ship. Beginning at the top of the mast, we have the surface search radar, which is an OPS-28. All these systems are based on American systems, but built in Japan. They're indigenous of American designs and performances. So the surface search radar, like I said, is the OPS-28. The ops radar, OPS-50, is the ASA style active ESA radar system. The NOLQ-3D1EW system is a combination offensive and defensive electronic warfare suite, right on the center mast there. You can see more of the OPS radar plates, those flat ASA radar plates, aft along the superstructure. They need 4 of those to cover 360 degrees around this rather large superstructure. Just below the flight deck on the starboard side, you can see the Mark 36 SRBOC, or SRBOC, which is a decoy launch system that launches a combination of different chaffs, flares, torpedo decoys, comes from the Mark 36. And then on the bow, because this is a submarine hunter, it does have the OQQ-23 bow-mounted sonar system, which is based on the American equivalent. Here's a close photo of that mast with those radars on it. You can see the OPS-28 surface search radar there, and right below that is the Ops 20E navigation radar. Those are high update, high fidelity, but shorter range radars. For example, when you're using a navigation radar, you're operating generally near a coastline, so you want to see that coastline very accurately. Also, a lot of small vessels will be operating near the coastline. So the Ops 20E is very good for that. You can see a great picture of the NOLQ-3D1 electronic warfare system and the SATCOM array that's next to it. I will mention that the NOLQ-3D1 looks very similar to the American SLQ-32 because it is based on that. It's not the exact same, does not have the exact same parameters, but visually it looks very similar to it. And I love this photo for how close you can see the Ops 50 flat ASA radar plates and get an idea of just how big those things are. Very powerful, continuous wave transmission, volumetric search radar. Here's the refit that's going on right now. So the refit is more than just a change from helicopter to aircraft. It is a complete change of mission for the Izumo-class. The Japan's, Self-Defense Maritime Force is designed to be defensive in nature and hunt submarines with these ships in a defensive, purpose. But Japan is going through a military and cultural change now from a defensive military to one that can project power offensively. And these ships are part of that change. So by switching or changing its operations to an aircraft carrier, it can conduct offensively capable missions. And that's what the United States F-35 Bravo is bringing to the two ships of the Izumo-class. The primary role will be switching from anti-submarine warfare to aircraft carrier missions. Here's the deck of the Izumo here. You can see it compared to a previous class, how much larger it is. It's quite an impressive beast. But again, Japan only has two of these, but both are going to be going under conversion to the F-35 Bravos. The smaller ship in this photo is the Hyuga class, much smaller. So both Izumos were built and commissioned in the 2010s. So the first one was commissioned in 2015, and Kaga Hull 2 commissioned in March of 2017. And they've operated as ASW platforms until 2024. The Izumo class by the numbers is quite straightforward. Like I said, she has 4 of the LM2500 IEC gas turbines. Those are spinning up, working together to propel the ship to over 30 knots. That's a key speed because she needs to be able to keep up with the American fleets and the Australian fleets with which she works with regularly now. The full load, the displacement, like I said, is going to be in the vicinity of 26,000 to 27,000, depending on how many aircraft and helicopters they have on board. You don't want to get too caught up by those numbers. Just understand the range of how much displacement these ships have. The crew is just under 1,000 total people with the aircraft crew on board. So it's ship's crew complement plus the air wing complement. Comes to about 970 personnel. She can carry 28 aircraft, 7 Seahawks or MCH-101s, or F-35 Bravos after refit. I expect this number to be updated after sea trials and all the operations that are going on now off the coast of San Diego, but we expect them to be able to operate 28 aircraft. She has, of course, the 4 total defensive weapon systems. 2 are phalanx, 2 are CRAMs. As far as sensors go, again, she has the Ops 50 ASA radar. That's the primary long-range search, air search, and can be surface search as well, combination radar. She has a dedicated surface search radar, the Ops 28, and her navigation radar is the OPS-20E. A bow-mounted sonar on a ship this large is not common, but she does have one called the OQQ-23 sonar system. The NOLQ-3D1 is the electronic warfare system that is both offensive and defensive, and the Mark 36 Serbach decoy launch system launches everything from combination chaff flares to torpedo decoys. She has a floating acoustic jammer and a 0 or an OYQ-12 combat data system that connects all these weapon systems and radars together so they can be displayed in the control rooms. Here's the LM2500 IEC gas turbine, very popular, very reliable, and easy to maintain system. It's derived from the GE military TF-39, and commercial CF-6 high bypass turbofan aircraft engines. It is a 2-shaft axial flow, simple cycle, can generate 33,000 ship horsepower. It's quite a bit. But this thing only weighs less than 5 tons per engine. And they have 4 of these on board working together. They don't have to run all 4 at the same time. That's what co-gag means. They can bring 2 up, they can bring 4 up, and still operate. Here's the OPS-50 radar, developed by Mitsubishi. This is a dual-band 3D surveillance and fire control radar. It operates in the 4 to 8 gigahertz for search and track, and then the X-band is 8 to 12 gigahertz for, I like to call, putting warheads on foreheads. That is the weapon guidance radar. Now, this is kind of an interesting place to be because all the weapons on board this ship are self-guided. They have the ballistic phalanx, they have the CRAM, which is a self-homing missile, but they do have the ability to guide weapons with this X-band radar if they need to. They have the GASAS ASA radar elements. The gas is the material that the ASA radar is made out of, which is important. It's a very high quality material. And the coverage is 360 degrees all the way around the ship with the multiple facing plates that go down along the side and forward and aft part of the superstructure. And this is a continuous wave illumination module. So it's very similar to volumetric search. It's just continuously transmitting in its direction, providing the data to the operator. Here's the OPS-28F radar. This is developed by the Japan Radio Company. It is an air and surface search, surveillance, and navigation radar. Operates in the 4 to 8 gigahertz range. That's NATO G and H band. So it's developed to detect track targets and sea skimming missiles. So whenever those cruise missiles are coming in, low to the ground, high speed, this radar will be one of the radars that will see it coming. Quite honestly, the ASA radar will probably see it as well, but this radar is very good at detecting it. This is a traveling wave tube, or TWT, and cross-power amplifier tube used for radar transmitters. This IOC'd back in the 1980s, but has been modified several times throughout the years. Like I said, these ships were commissioned in 2015, 2017, so they have very modern designs to this older system. Here's the OPS-20 radar, developed by the Japan Radio Company. It's a 2-dimensional air and surface search radar. Notice how there's so much redundancy here. All these radars are dual purpose, air and surface search so far. This operates in the X-band, 8 to 10 gigahertz. Pretty high update rate, but because it's a navigation radar, you really want that so you get, 1, detections on small craft, very important, and then of course the coastline. This will literally on the display show you the edge of the coastline within range of the scale that you select on the display. It's developed to track and detect surface contacts, like I said, uses a composite antenna, which means it has a main and a sub antenna, and it is a continuous wave with reduced detectability integrated into the system. That is the OPS-20 radar. Here's the NOLQ-3D1 electronic warfare system developed by Mitsubishi Electric. This is a combination ESM and ECM suite, like I said. Fully digital system, very modernized, looks very similar to the American SLQ-32, which it is based on. It has multiple antennas arranged at 45 degrees centerline from the ship, giving a total of 360 degrees of coverage. This detects radars, it classifies them, it gives that information to the operator, and offers jamming functions for the radars that it detects. All in one suite, IOC'd in 2018. A very good ECM system. Here's the Mark 15 Bravo Phalanx close-in weapon system developed by General Dynamics. This is based on the M61A2 Vulcan rotary cannon shooting the 20 millimeter APDS ammunition. It can shoot down and up. This is an important fact in modern warfare with unmanned drone warfare coming on, across the surface. This gun can look down, shoot down, and destroy close-in targets, as well as any aviation targets that come within range. It fires about 4,500 rounds per minute. There are different modes with different rates of fire. Just know that they keep about 1,500 rounds in the magazine at any one time. So it can burn through that magazine really fast. Effective range is about 3.6 kilometers, and that really depends on your target. It is both radar and electro-optical guided. You can also take manual control of this from inside the ship, CIC room. It has multiple sensors on it: visual, radar, infrared, forward-looking infrared. This variant is from 1999. It's very reliable. That's why it still works. We have some great graphics here for you to show you some of the ammunition and a detailed breakdown of the antennas that are inside the Mark 15 Phalanx. You have the video trackers on the side. The main R2-D2 looking hub actually houses a low sideband track antenna. So that's what's inside there. And on the top of it, at the dome portion, is the search antenna. Here's the CRAM Point Defense Missile System. Uses the same, or very similar, radar tracking system that the CWIS uses, but this is launching up to 11 RIM 116 RAM air defense missiles. These are used for standalone point defense, fire and forget. Has an effective range of about to 15 kilometers with the Block 2 missile, used to shoot down low-flying aircraft and incoming cruise missiles. This is a very fast missile, and it's a point and shoot. Very simple. This IOC in 1998. Here you can see a breakdown of the sensors, which are pretty much the same as the CWIS. And here's a great photo of the RIM 116 Charlie Block 2 missile. This is the one that can go out to about 15 kilometers. This is a very accurate missile. All right, here's Japan's version of the SH-60 helicopter called the SH-60J. It's very similar to the American one in performance in terms of it has 5 hours of endurance. It can carry multiple weapon systems, including Mark 46 torpedoes. It can fire the AGM-114 Hellfire missiles if it had an ASUW mission. You can also mount 7.62 machine guns in the door, and it has the HPS-105 search radar. That's that large flat disc that you see right under the pilot. That's the radar, surface search radar. It also has a sonar buoys and MAD detection, forward-looking infrared, a very capable helicopter. Here's some of the torpedoes that it could fire. A Type 12 torpedo would be the Japanese version of the Mark 46. There's the AGM-114 Hellfire, and there is the door-mounted machine gun. The operator, the crew chief, if you will, on the back there can get on that if he needs to. Those are not always, or I would even say normally, installed. All right, here is the queen of the ship right here. This is the new capability that they're getting. It is the F-35 Bravo Lightning II. This is a 5th generation fighter, vertical takeoff and landing aircraft. It has one F-135 afterburning turbofan and a lifting fan. Many people don't know that when it's doing the vertical takeoff and landing, there's an additional fan in there to help keep the nose up, because the exhaust from the engine itself is in the rear. So to balance things out, and we have a great photo of it coming up for you, there's an additional lift fan. The max speed of this when it's in the air and in horizontal flight is 1.6 Mach. Quite impressive for a VTOL aircraft. It has lots of stealth characteristics that we can't go into. Just understand that it is 5th generation, very low probability of detection, and you aren't going to put a weapon on it. A radar-guided weapon is not going to get on this. As far as heat signature goes, it has multiple systems to diffuse its heat signature, so you would have to be very close to get an infrared guidance on a weapon on this aircraft. It has its own electrical optical system. It has directional awareness systems because there's multiple sensors all the way around this aircraft. And it is very good at coordinating a fight. Think of this aircraft as a quarterback in an air battle. It can even coordinate action on the ground and at sea. So it can take in data from multiple sensors, including its own, of course, which are quite powerful, and then share that data with other aircraft, like say the F-18, for example, who may not have the target. But this aircraft, one of its many purposes would be to help other platforms employ their weapons with target guidance and data link from this aircraft. Here is the laundry list of weapons that the F-35 Bravo can carry. It is quite literally everything in the U.S. Navy and Air Force arsenal as far as air-to-ground and air-to-air goes. Everything from the 2,000-pound paveway down to the 500 or the 500-pound paveway. She can carry the Storm Shadow, which has garnered quite the reputation in Ukraine and Russia war right now, as well as the JSAM and other cruise missiles. Air-to-air missiles, she can shoot everything from, the AMRAAMs to the Sidewinders, so short, long-range, radar-guided, infrared-guided. She has quite the laundry list of capabilities, both external and internal. Now, there are limitations on what can fit in the internal tank. And on the screen here, if you're watching the video, you can see the weapon systems that will fit inside this aircraft so that it can maintain its stealth characteristics, and the weapon systems that would need to be on the wings. And if you did that, you would lose much of your ability to remain undetected. The lower right-hand corner, by the way, is the great photo we found for you showing you the lift fan. The lift fan is used during takeoff and landing and helps keep the plane, level as you go up and down. That normally is not used during horizontal flight. All right, final thoughts. The Izumo-class helicopter carrier is quite impressive as an ASW platform because it can employ, more than 24 aircraft searching a large area of the ocean around Japan looking for submarines. It's very capable, and it has its own built-in hull-mounted sonar system. So very good ASW platform. It can go and control an entire area and deny access, essentially, to submarines operating in that large area. But what's really important here is the change that's happening in Japan. This is a cultural shift. This is a military shift. This is a different way of thinking. They are going from becoming a maritime defense force to an offensive capable Navy and military in general. And one of the big steps in that is converting these two ships that are of the Izumo class to aircraft carriers. And that is in progress. That is happening right now. It's very important. One of the reasons why this is happening now in this cultural shift is the aggression we're seeing out of China. China is a big purpose, a big reason for this capability being needed now by Japan. Japan clearly did not want to do this, but after seeing how China's been behaving for going on 25 years now, since the mid-90s, they're learning that China will not stop its expansionistic endeavors until they meet a force that can stop them. And that's why Japan is increasing its military budget and its military capability, and the Izumo-class conversion from a helicopter destroyer carrier to the Izumo-class aircraft carrier is happening. And the United States is helping them do it. And like I said, a little extra for you is as we're recording this, the sea trials with testing and operating and learning how to do operations with F-35 Bravos is happening right now off the coast of San Diego with the Marine Corps Aviation Air Crews. And happy to see it because we need all the help we can get in the Pacific. And these are strong allies, and having a stronger ally is good for everyone. So this is the Izumo-class helicopter carrier lecture. Thanks for listening, everybody, and we'll see you in the next one.